very new and interesting thing. Have you ever wondered the most important and very commonly used component of Arduino, servo motor? Today we'll be learning that and we'll be knowing how to program it using a library. And it will be really very interesting and fun to do it. So now I'm going to show you how to do that. But have you ever wondered, rather than a LED or a buzzer, it has three pins, which are PWM pin, positive pin, and negative terminal. It has one more pin which is called as PWM. What do you come to know by PWM? PWM stands for pulse width modulation. So what is pulse width modulation? In the last class, we had learned how to send varying voltage to our LEDs or buzzers. This can be done using pulse width modulation or analog rate function. These analog rate function can be used only in the pins which have the pulse width modulation mark in the digital pins group. So today I am going to show you which pins have the digital pins group. So 1 minute. So it's opening up. Yes, I have saved the image. Now I'm starting to share my screen. Okay. Can you see this? I'm magnifying it so that you can see it better. So this is our Arduino Uno board, which we normally use. This is the original one. So can you see digital and here PWM, and it has a sign which the digital pins 11, 10, 9, 6, 5 and 3 have. Means total there are 14 digital pins, out of which only 6 digital pins have. So whenever you want to use analog write function or use the pulse width modulation pins or which can send varying voltage, you will have to use the digital pins 11, 10, 9, 6, 5 or 3. Okay, so this is what you should need to remember. You can't send varying voltage using digital pin 13, 12, 7, 8, 2, etc. etc. Because these pins can send only a constant 5 volts or 0 volts. You can't send varying voltage. This can be done only using digital pins 11, 10, 9, 6, 5 and 3, which are marked by the PWM sign. Okay, so I'm stopping to share my screen and I hope this is clear to you. Okay. So now we know pulse width modulation. So the pulse width modulation pins in our Arduino need to be connected to our servo motor, which I had recent and just now told you. So one of our pins will be connected to our servo motor. So that's clear. Let's now begin to code it. But before that, one interesting thing. If you take a look at the 9 servo SG90 servo motor, it looks quite tiny. However, it has high torque, much more than the normal bow motors we use. It is quite good and really it's amazing. It can rotate accurately up to 0 to 180 degrees. And now I'm going to show you how to do that. Are you excited? So let's start screen sharing. I'm again starting screen sharing and yes, it's done. I hope you can see my screen absolutely clearly. Now I'm going to open Arduino IDE app. So that's done. Open up. It always takes a little time. However, Arduino IDE beta version is quite fast, as you saw. It opened up in Sura's time. Okay, so this is our new window which I have recently opened. Then it's ready. Yes, it's absolutely ready. I'm increasing the font size a bit, as you can see. So I don't know what's happening. Okay, so we can start writing our code. So first of all, as we are going to use a servo motor, let me select the our Arduino Uno board because this is the latest version. It has many hi-fi features as well. So Arduino Uno, okay. Done. So it is selected. Now we will be adding our library, Servo library. It's named as Servo and it is pre-installed. No need to install it. So as you can see, this is the library Servo. Yes, it's done. I have added it. But whenever you're using any library, nearly any library, you must create an object. Okay, so you're using the library name. So what's the library's name? Servo. So we'll be using the same servo and keeping a space. You can give any object. Like now I'm giving my servo and a semicolon. Remember, semicolon is what differentiates, so that is must. So first we include the library, then we use the library's name to create a servo object. That is this, my servo. And in void setup, we are not going to classify it as output or input because in the library it is pre-classified that it is output. So we'll be simply attaching it to a digital PWM digital pin. So for reference, I'm again opening the image so that it will be more easy. Okay, so I will again magnify it. I will again see it. So here, as we can see, the digital pin 11, 10, 9, 6, 5, or 3 can be used. So now I will be using digital pin 11 for this. I will go here and now we will be attaching it. How do we attach it? So using the our object created using the library name my servo dot attach. Then it's simple. Simply write the name of the servo object and dot attach. So to which digital pin we are going to connect it? We are going to connect it to digital pin 11. So we give the number. And then in loop, what is there? We will have to rotate the servo. It's quite easy, right? But today we will be learning something more, a little more interesting. That's for loop. Have you ever heard? You might have heard about if conditions, else condition, or else if condition, but you might not be that familiar with for loops. So let's make it easy. For loop, bra. First we write for loop, then shift 90 brackets, and then curly brackets. And in shift 90 brackets, I'll be writing int I. Why do we use int? To create a variable? Yes. So we create a variable I, int I is equal to 0, semicolon, till I is lesser than 180, I is equal to plus is equal to 1. That means that first we declare a variable for our code, that is I, and then till I is lesser than 180 degrees, it will keep on adding itself. Continuously, one will be added to it, added to it, added to it until it is greater than or equal to 180. Okay, so now we'll be writing. So how will we turn it according to our wish or angle? That's simple. My servo dot my servo and dot we write servo dot right. So dot right helps us to give it like any angle. Okay. So here we have created an angle I. You see here we created a variable I and its starting value is 0 and it is previously 0. So it will be definitely lesser than 180. It is common sense. Okay. So until it is greater than or equal to 180, I will increase its value plus 1, plus 1, plus 1, plus 1. Okay. And we keep a delay here so that it will increase its value slowly. So we give a delay of, how about 100 milliseconds? It's quite less, but that makes it very smooth. Okay. So the total from changing I to 0 to 180, do you know how much time it will take? It's simple. 180 into 100, that's 18,000. It will take 18,000 seconds or 18 180 millisecond. Sorry, seconds. That means 3 minutes to be accurate. This is how it is done. And now we have created a variable in for loop then we declared its value as 0, then until it is equal to or greater than 180, it will keep on adding 1. So now our servo can move from 0 to 180. But what if it wants to go from 180 to back to 0? It can't be done, right? So now we will be giving one more if a for loop condition. That's again int I is equal to 180 semicolon I, oh no, I is greater than 0 semicolon I is equal to, sorry, oh no, 1 I minus is equal to 1. And then I go in the brackets and my servo dot write I, and we keep again a delay of 100 seconds, sorry, 100 milliseconds. So this is how everything is done. As you can see, we created a library, all that thing. But before, like as every time I do, I add comments and make it more clear. I would like to introduce to you for loop because it's the first time and you might be a bit confused about it. So what is for loop basically? For loop, as you can see, for loop int I is equal to 0, I is lesser than 180, I plus is equal to 1. So it might be a bit confusing, but that's the format. I'm again going out of the brackets just to show you how what exactly is for loop. So first, whenever we want to use for loop, we give three parts in it. First is to declare a variable in it. You can give any value to it. Here I'm giving it 0 and I. Then we have to give a condition. This has three parts. Yes, done. Okay, so these are the this everything. So these are three parts if we see clearly. If we differentiate between each and every semicolon. First, what the part is, int I is equal to 0. Here we declare a variable in it and give it a value. As I had told you in our previous class, we can give a value to a variable to store it in. And then I is lesser than 180. That is a condition. Till I is equal to, till I is lesser than 180, I plus is equal to 1. That means I will keep on increasing its value by 1. And then we give a delay of 100 milliseconds so that it keep on adding 1 to itself after 100 milliseconds. Okay. So first, what do? We create a variable in which we add the value 0. Okay. And then after adding the value 0 to the variable which we had written in our for loop I, we give a condition till which the code will be executed, and the code will be which will be executed must be in the flower bracket. So this is what will be executed. So till it is lesser than 180, I will increase its value by 1. Okay, so this is everything. Now I am again going back. Understand? So now I will be commenting the code and telling you at the same time what we have done. So first we add a library. Then we create a servo object using the library name. And then in white setup, what we do is we simply attach it to a digital PWM digital pin. So we attach it to a digital pin 11, which is a PWM pin. Attaching it to a PWM digital pin. And this is the main part. What is it? Void loop. So void loop might seem you a bit difficult because you're a beginner, but you must memorize it. Okay, I can't help anything in it, but there's a way more simple, but it's not that great. Okay, what here is the servo will automatically rotate from 0 degrees to 180 degrees, and again from 180 degrees to 0 degrees, and that's automatic and much more cooler. Okay, so this is why we have added for loop. But if you want, you don't want all this, and you want that rotate, the servo should rotate according to your given angle, then there's a way. What we have done here is my servo dot right eye. So whatever angle you want the servo to rotate, you can simply give it like this. My servo dot right the angle. For example, if 60 degrees you want, so write 60. If you want 100 degrees, so write 100. If you want 3 degrees, write 3. It's your wish. Okay, so that's clear. First, we create a servo object, then we attach it to a digital pin, and then it's the main thing is for loop, in which we create a variable in a for loop, assign it a value, and give a condition. And the code which is given in the flower brackets will only execute if the condition is true. So we created a variable I and assigned a value 0. And we gave a condition after semicolon that until I till I is lesser than 180. If I is equal to or greater than, this will not execute. Till I is lesser than 180, I will increase its value by 1. Is it clear? This is what we have learned here. And as I told you, there's one more method for this. I will delete all that and directly simple method for you beginners. My servo dot write and directly your angle. For example, from starting we will write 60 and then we give a delay so that the next angle which we are going to be writing will have a pause. So we give a delay of 500 milliseconds, and then again my servo dot write 120. Then we again give a delay of 500 milliseconds. What I'm showing you is actually very easy. Okay, but because you're a beginner, you may use this technique as well. My servo dot write. What are we writing now? Dot write 180 degrees. We simply added 60, 60, and 60. And then we again give a delay of 500 milliseconds. Now, one more thing which I forgot to add is that we will have to start it from 0 degrees because we are adding 60, 60, 60, and when it becomes 180, it will directly go to 0. And then again 60, 120, 180, and again to 0. Or it is like your wish, okay? But I wanted to add it. This is why I have written that. Delay 500 milliseconds. Done. So this is all for our today's class. I will shortly introduce and give a brief summary so that you understand clearly. Okay. So first, what we have done is we add a library for controlling servo motor. Okay. Then we create a servo object using the library name. So we added a library called as servo.h. So using the library name servo, we use servo and then a library name. Sorry, the object name. So the object we have created using the library name is my servo. So whatever object you create, like whenever you create a connection, you have to use that, okay, to control that connection. So similarly, the object you create using the library name should be used to control the servo motor attached to that. So we use the object you created using the library name and attach it to a PWM digital pin as shown here. I attached it to PWM digital pin 11, and then Here is our main code. We add the library, create a servo object using the library name. We attach it to a digital pin, and the main thing what we do is in void loop. So in void loop, we can simply turn the servo motor according to our wish using dot right and in shift 90 brackets the angle control. Oh, sorry, controlling the servo motor's angle, keeping a delay of 100 milliseconds. Okay, so this is all. I have not written added comments here because it simply wastes time, and I want to make you clear. Okay, I don't want to show that how great I am in coding. I want to make it clear for you. So as we have added comments and it is easy to coordinate with what I tell, I'm explaining it to you. First, control a servo, there are four steps. Step 1, add a library called servo.h. After adding the library, create a servo object using the library name. So we use the servo, the library name, and using that we created a servo object called myServo. And then attach it to a PWM digital pin as done here. Then in main thing what we do is in void loop. So this is our fourth step. First step was adding a library. Second step was creating a server object using the library name. Third step was attaching a PWM digital pin to it. And the fourth step is to control the angle of our servo motor. So the controlling of our angle of servo motor is quite simple. The part which I'm highlighting clearly demonstrates it. My servo, which is the servo object's name, dot write, and in shift 90 brackets, we write the angle. Here the angle is 0. So whatever angle you write here, my servo dot write, if you write 90 degrees, it will rotate to 90 degrees. If you write 20 degrees, it will rotate to 20 degrees. I have written 0, so it will rotate to 0 degrees. Then kept a delay and I changed the angle of our servo using my servo dot right, and in shift 90 brackets I gave the angle which is 60 degrees. Okay, I hope it is clear, and let's do a final job which is saving it and testing it. So I am saving it and it's saved, I think. Yes, saved. Now I will be opening it. Saving, opening time. So this is all. Everything is clear. And this I think it will take a whole year for opening up. Open up, open up, open up. This is the most horrible thing about this. Open up, please open up. Okay, open up. So as you can see, this is our code. Let's verify it. And I'm 100% sure that it was going to be correct. And yes, verified. Done compiling, and that's done. If a red line comes here, that means the code has some errors and so, and we have to correct the errors. So we added a library, we created a servo object using the library name, we attached it to a PWM digital pin, then we controlled the servo motor's angle using dot right, the servo object created, and dot right 0, dot right and shift 90 brackets, the angle. Okay, I hope you liked today's tutorial, and hello. And I hope you liked today's tutorial, and I'm really very happy that I could teach you how to use the servo motor. And bye bye.